So you've all been asking for help with probability, so we'll start with a nice easy one. This is called a frequency tree, and it's something which is new on the GCSE, but it's actually really simple. So 50 people took a test. Before the test they predicted whether they would pass or whether they'd fail, and we've got 30 of them that were predicted to pass. So we're going to look at this column here that says prediction, and 30 of them are predicted to pass. Now before I do anything else, I'm just going to work out that that means 20 of them are predicted to fail. 26 of the people who were predicted they would pass actually did pass. So 26 is going there, which means that 4 of those 30 failed. And then 37 passed altogether. So this one and this one have got to add up to 37. So that one's 11, and because there were 20 that failed, that one's got to be 9. Nice and simple. So this next one is to do with Venn diagrams, and it's about set notation, and it tells us that in the question that we're on about sets. Now sets are just basically lists of numbers, but we write them in a fancy way. So this symbol here means the union, and that basically is just a fancy way of saying or. So we want all of the numbers that are in A or B. Now you don't have to, but normally I would just write them going up. So we've got 10, 12, 14, 15, 16 and 18 using curly brackets. And then this symbol means intersection, which is just a fancy word for overlap, and it means and. So which of those numbers are in A and B, and that's just the 12 and the 18. Okay, so then part B is just about this set A dash. Now this little apostrophe here basically just means not A. So we want all of the numbers that are not in A. So first of all, I'm just going to circle those on the diagram. So I've got 11, 13, 17, 19, and then I've also got these 3 that aren't in the circle A. And I this time want the probability, not just the number. I don't want to just list them, I want the probability. So I've circled 7 of them, and in the whole diagram, because that's what I'm on about, one of the numbers in the diagram, I've got an extra 3. And so my probability is 7 out of 10. Obviously you can write 0.7 or you could write 70%. So now we need to put numbers into the Venn diagram. So this symbol just means that these are all the numbers that need to go in the diagram, so don't forget about the ones that aren't in the 2 categories given. So we'll look at these 2 separately. We've got square numbers, 1, 4 and 9, and then even numbers, nice and obvious. And then the only one that's in both is going to be the 4, so we'll put that in the intersection there. So now I've got a 1 and a 9 to go in square numbers, and the even numbers that are left are 2, 6, 8, 10 and 12. And then this is what some of you always forget to do. You've done all that and then you move on to part B. But actually you still need to include the numbers that we haven't looked at yet, which are the 3, 5, 7 and 11. So you can just put them on the outside somewhere. And then this stands for probability, and this stands for intersection, so that's like and. So we're looking at the middle part, and there's only one number in it out of, and we can just look at the top bit here, there were 12 numbers altogether. So that's that one. Okay, so these are probably the trickiest Venn diagram questions, just because they don't actually mention that you need a Venn diagram in the question. And some of you I know on the exam tried to do questions like this using a table, which is fine, but for this kind of question, a Venn diagram's a lot easier. So you'll see my dodgy circles now. We've got the first one, a T, second one for coffee, and the third one for milk. So we've got 50 people all together. I'm just going to keep that circled at the top so that at the end I just check that it adds up to 50. And I'm just going to work my way through and tick things off or cross them out when I'm done with them. So all 50 people like at least one of the drinks, which means that all of those 50 people are going to be inside these circles here. So I don't need a box around them, that will do. I've got 19 people that liked all 3 drinks, so 19 people are going to go in the middle. So I'm just going to label these so I don't lose track: tea, coffee and milk. 16 people like tea and coffee, so I'm talking about the intersection between tea and coffee, but they don't like milk, so they're not going to be included in this 19 bit here. So I've got 16 that are going to go in that section. So I'm going to cross that out because I've done that part. 21 people like coffee and milk, so I'm looking at the intersection between coffee and milk. But it doesn't say that these 21 people don't also like tea, so I'm not sure whether those are included or not. So I've got to definitely subtract the 19 that's already there. So 2 goes in there, so that altogether 21 people like coffee and milk. Done that one. 24 people like tea and milk, so this is the same thing. I've got 24 altogether in this section. And so I need to have 5 going in there. Dealt with that one. 40 people altogether like coffee, so I'm now going to look at just the coffee circle up here. So I've got 16 and 19, which makes 35, and then I've got another 2, so that's 37. But 40 people like coffee altogether, so there's got to be another 3 people that only like coffee on its own. And then it says 1 person likes only milk, so they've already done that section for you. 1 person goes in there. Now all we've got to do is figure out what goes in this last section. So we said that in the coffee circle there were 40 people, and then I've got an extra 5 and an extra 1, so that is 46. So 4 of them have got to like just tea on its own. Sammy selects one of these people at random, so there's 50 of them, we know that from the beginning, and we want the probability that this person likes tea. So we look at the tea circle and we're going to just add these ones up, so 16 plus 19 is 35, add on the 5 is 40, add on the 4 is 44, and then what we always do with a fraction, when we can do, is just cancel that down. And then last part, given the person selected at random likes tea, so we already know that they like tea, and we've just said that that was 44 people. I'm just going to keep that there. We want the probability that this person also likes exactly one other drink. So when we look at the circle for tea, the people that like exactly one other drink is these 16 people that like coffee as well, and these 5 people that like milk as well. But we don't want these 19 people because they don't like exactly one other drink, they like 2 other drinks, so we're not including those ones. So we just want the 16 and the 5, so our answer is 21 out of 44. Okay, so John has got an empty box and he puts red counters and blue counters in it. That doesn't tell us anything. The ratio of the number of red counters to blue counters is 1 to 4, and you'll all know by now that I like to just write it really simply. Red to blue is 1 to 4, so I've dealt with that. And Linda's going to take 2 counters from the box. Don't know why it's always a random name. So 2 counters from the box, and the probability that she takes 2 red counters is 6 over 155. So we've got the probability of taking a red and then another red is 6 over 155. And we want to find out how many red counters were in the box. So I'm going to call the number of red counters x, which means that there are 4x blue counters, and then I'm just going to work it out just like you would normally if you didn't know what the probability was anyway. So the probability of choosing a red and then a red is the probability of choosing a red the first time, which is just x, because there are x red counters out of 5x altogether, just by adding the numbers in the ratio. And then for the second time, so once they've already removed one of the red counters, there's going to be one less red one, and there's going to be one less in total. So now I'm just going to look and see how can I simplify that. So the first thing that I can do is I can cancel these x's here. So I've got just 1/5, and that stays the same. Can't cancel anything there, that's in its simplest form. And then to get rid of this 1/5 that I've got here, I can just times both sides of this equation by 5. So I'm going to do that. And I could leave it like that, but I'm going to just simplify this bit now so that I know that I've done it. I'm going to divide the top and the bottom by 5, so I get 6 and 31. So now all I'm going to do is, looking at these parts here, I'm going to just cross multiply. So what I've got is 31 lots of x minus 1 and 6 lots of 5x minus 1. And I'm just going to multiply it out as if it was like year 7 maths. So 31 times by x, 31 times by 1, 6 times by 5x, and 6 times by minus 1. And then I'm going to subtract 30x from both sides. So I'm left with x minus 31 equals minus 6. And then I can just add 31 to both sides and get that x equals 25. And remember, x was the number of red counters, so we've already answered the question. So this question's got basically 4 categories. We've got that they arrive by car or they don't, and we've got boys and girls. So 40% of them are boys, so I'm just going to write it down a bit like a ratio. So I've got 40% are boys, so 60% are girls, and out of the boys I've got 70% of them that arrive by car, which means that we've got 30% of them that don't arrive by car. So then I'm just going to do the same for the girls. I've got 60% of the girls which arrive by car, and so not by car has got to be 40. So I've not even read the question yet, I've just summarised all that information so it's nice and easy. What is the probability that a child chosen at random from the nursery arrives by car? So all I want to look at is basically the probability that I've got a girl that comes by car and the probability that I've got a boy that comes by car. And those are quite easy to work out. So we'll start with this one. A girl that comes by car is obviously going to be 60% of 60%. So I'm going to use decimals because it's the easiest way. So I'm basically saying that I've got 60% of 60%. And then for the boys, the ones that come by car, that's 70% of the 40%. So 0.7 times by 0.4, which is 0.36 plus 0.28, which is 0.64. If they want it as a percentage, then you'd write 64%, and as a fraction, you'd just cancel that down. And that's it. So we've got Y black socks and 5 white socks, and we are taking 2 of them at random, and we want the probability of 1 Y sock and 1 black sock is 6/11. So just notice here that it doesn't say the word then. It doesn't say we're taking one white sock and then one black sock. It's just saying basically we want one of each. So we want the probability of taking a white and then a black, or we want a black and then a white. And when we want or, so when we want two possibilities, we need to add those probabilities together. So I'm just going to start by working out this first one. So a white sock, there are 5 of those out of y plus 5 in the drawer, and there are y black socks, and this time we've got y plus 4 that are left in the drawer. So I'll just simplify that. That's 5y over, and then to multiply the denominators, I'm just going to use FOIL. And then you can work this out for yourself, but you would see that this probability here of a black and then a white would work out exactly the same. So when I add them together, I'm going to get 10y over y squared plus 9y plus 20. And I'm told that that's equal to 6 over 11. And then I can just cross multiply like you usually do end up doing with these ones. So I've got 110y equals 6 lots of that denominator. Just going to multiply this out. And then you can either rearrange and then simplify, or you can do it like I'm going to do. I'm going to divide everything by 2 first. And the reason that I'm doing this is because in the question, sorry, that should have been a 120 there. In the question, we're aiming to show that we've got 3y squared, so that's why I've halved it already. And then if I take away the 55 from both sides, I'm left with minus 28y, which is in the question. Now, part B in this case is asking us to find a probability. Now, we can only do that, we can only find a numerical probability if we actually know how many black socks there were. And that's why part A is leading us to an equation where we're going to be able to solve that and find the number of black socks. So even if you couldn't do part A, you can use that equation to do part B. So we've got 3y squared minus 28y plus 60 equals 0. Now if this was on a calculator paper, then obviously the easiest thing would just be to use the formula. But if it wasn't, then you would know that this factorises, which in this case it does. So I've got to have numbers which multiply to make 60, and we've got to end up with minus 28y. Now obviously the easiest one, it would be a 6 and a 10, and I know that 3 lots of 6 gives me 18. So they're going to go like that, and they both need to be negative so that they multiply to make a plus 60. So the two solutions that this would give me are 3 1/3 and y equals 6. And remember, y was the number of black socks, so the obvious solution is that it's going to be this one. The number of black socks is 6. Now, the question didn't want to know that, it wanted to know the probability of taking 2 black socks. So the probability of taking your first black sock is 6 out of, in total we've got 6 plus 5, which is 11. And then the second time, if we've already taken one of those out, it's going to be 5 over 10, which is 30 over 110, which is 3 over 11. We've got 10 pens in the box, we've got X of them are red, all of the others are blue, so that's 10 minus X, and remember these two add up to 10. So we're going to take 2 pens from the box, and we want an expression in terms of X, that just means X is going to be in the answer, for the probability that he takes one of each colour. So it's the same as before, we kind of want a red and a blue, or we want a blue and then a red. So I'm just going to start by working those out. So a red and then a blue. So there are X red pens out of 10. And then the blue ones, we've got 10 minus X, that hasn't changed. And this time we've already taken one out, so the total is 9. So I'm just going to multiply those together. And then we'll do the same for blue and then red. So blue is 10 minus X out of 10. And the red ones, there are X. And this time it's out of 9. So you'll find that it's exactly the same as the first one. So remember, I wanted to add those two together. So we're looking for 2 lots of that. So we've got 2x brackets 10 minus x over 90. Again, I'm just going to simplify this. So I'm going to divide the top and the bottom by 2. And you don't necessarily need to, but I'm just going to expand the top part as well. And remember, it just wanted an expression in terms of x for the probability, and that's what we've done. We can't simplify that any further, so that is the answer there.